What are the different types of welding methods? Welding is the process of joining materials by fusing them, using heat, pressure, or a combination of both. It's used in everything from skyscrapers and pipelines to surgical tools and spacecraft. But did you know there are many different types of welding, each suited to specific tasks and materials? In this video, we'll explore 18 major types of welding, their uses, and their unique benefits. Shielded metal arc welding, SMAW stick welding. SMAW is one of the most common and affordable forms of welding. It uses a coated electrode to produce an arc and create a weld. It's rugged, portable, and ideal for outdoor or heavy-duty work, especially in construction and repair of steel structures. Gas metal arc welding, GMAW welding. MIG welding uses a wire electrode and shielding gas for clean, continuous welding. It's known for high speed and ease of automation, making it a go-to method in automobile manufacturing and light fabrication. Gas tungsten arc welding, TIG welding. TIG welding uses a non-consumable tungsten electrode and inert gas, usually argon, for precise control. It's perfect for thin metals, stainless steel, and aerospace components, offering a clean, high-quality finish. Flux core arc welding, FCO. FCO uses a flux-filled wire electrode, which can shield itself without gas. It's effective on thick materials and performs well in outdoor environments, like shipbuilding and structural steel. Plasma arc welding, PO. Similar to TIG, PO uses a plasma torch to generate heat. It allows for deep, narrow welds with excellent control, suitable for high-precision jobs in aerospace and electronics. Submerged arc welding, SMAW. SMAW involves a hidden arc beneath a layer of flux, which protects the weld pool. It's ideal for long, straight welds in large-scale projects like bridges, tanks, and ships. Atomic hydrogen welding, AHW. This rare method uses a hydrogen arc between two tungsten electrodes. It's known for extremely high temperatures and is best for welding high-purity metals, though it's largely replaced by TIG. Oxy-fuel welding, gas welding. Oxy-fuel welding, especially oxyacetylene, uses a flame to melt metal. It's versatile and doesn't need electricity, often used for metal art, plumbing, and sheet metal repairs. Resistance spot welding. This method joins thin metal sheets by applying pressure and electrical current through electrodes. It's fast, clean, and heavily used in automotive assembly and appliance manufacturing. Resistance seam welding. A variation of spot welding, seam welding uses rolling electrodes to create a continuous weld. It's excellent for leak-proof joints, such as in fuel tanks and radiators. Friction welding. Friction welding joins materials by generating heat through mechanical friction, followed by pressure. It's perfect for joining dissimilar metals, often seen in aerospace and drive shafts. Friction stir welding. A solid-state technique where a rotating tool stirs and joins metal without melting it. It's ideal for aluminum parts in aerospace, trains, and automotive applications. Ultrasonic welding. This method uses high-frequency vibrations to bond materials, primarily plastics. It's widely used in medical devices, electronics, and packaging, offering precision without added heat. Diffusion welding. Diffusion welding applies high heat and pressure over time to allow atoms from different surfaces to merge. It's highly precise and used in aerospace, nuclear, and advanced manufacturing. Electron beam welding, EBW. EBW uses a beam of high-velocity electrons in a vacuum to melt and fuse metals. It allows for deep, narrow welds with minimal distortion, perfect for aerospace and microfabrication. Laser beam welding, LBW. LBW uses a focused laser to join materials with pinpoint accuracy. It's fast, clean, and used in automotive, aerospace, and medical device manufacturing. Thermite welding. Thermite welding produces intense heat through a chemical reaction of aluminum and iron oxide. It's used for joining railway tracks, heavy steel sections, and infrastructure. Forge welding. One of the oldest welding techniques, forge welding involves heating metal and hammering it together. Though mostly traditional, it's still used in blacksmithing, artistic metalwork, and restoration. Conclusion. Welding has evolved into a highly diverse field, with each type offering specific strengths for different materials, conditions, and industries. Whether you are fusing aircraft components with lasers or building bridges with submerged arc welding, there's a method tailored to your needs. Mastering the right technique ensures not only strong and lasting joints, but also greater safety, efficiency, and quality in fabrication.